Okay, so I'm just getting off work, so I'm kind of still switching gears here, but hopefully at least the microphone is working. And I'm going to pick up where we left off 2 days ago on the chess engine. And a few people asked what language we're building the chess engine in, and I'm going to be building the first version here in Python, and then perhaps at some point um, if it ends up working out at a basic level, then maybe we'll rewrite this in C Sharp, or I've been thinking about using it to, or rewriting it in Rust perhaps as well. But yeah, so that's what we're gonna do this evening is, for a few hours anyway, work on getting through some more of the engine in Python. So let's see. I did do some work yesterday. So I'm gonna see if I can switch up my screens. So hopefully you guys can see this. I'm also gonna try to bring in a second, see if I can bring in a second monitor, or a second embed here. Just one moment, sorry about that. Let's see if I can add an overlay. Also, if anyone shows up, would you let me know if the audio is working? All right, let's see. Sorry, I have to take care of a few things here for the moment. Hey, B Marsh. I'm still getting set up here. Sorry for the delay. Okay, cool, thanks. All right, picture in picture should be set up. Let's see. There we go. All right, that took long enough. Okay, so as I was saying, I did do a little bit of work on the Bitboards that we started a few days ago, so I can walk through what I've done here so far. So I'm still updating the Jupyter notebook with just any notes that I feel like taking as we go along, and also just using it as a place to sort of explore how these bitboards work, and sort of play with the various features of the code. So yeah, so basically we have this board class, and I should just get the code open as well. So I'll pull that. So I'll pull this up here. Try to make it bigger. And as soon as my terminal wakes up, we will take a look at the code. So we've got this board class and a few methods on it. It gets initialized, and we set bitboards for each group of pieces on the black and white side. So the pawns, for like the white pawns have a bitboard, the black pawns have a bitboard, the white rooks, the black rooks, the white knights, white bishops, white king, white queen, and then likewise for the black side. So we have bitboards for each of the sort of classes of pieces. And we have this pretty print function, which basically just takes in, well, we can stack various bitboards using bitwise operations. So we can do like logical ands or ors to compose various bitboards, and that's going to be, I think, really useful for later on in move generation when we're looking at sort of like attacking pieces and that sort of thing. So we can do, for instance, we can pretty print the white king here, which starts out on E1. Black rooks. We have a way to basically get the empty board squares, and we can take a look at that in code. Basically, we just subtract 1 from the, or we take 1 minus the bitboards where the current piece locations are, and this gets us the open squares. So in the starting position, it's the 3 ranks 3 through 6, or every file rank 3 through 6. We have bitboards for queen side and king side. So a lot of times when we talk about chess positions, we talk about whether or not a player is attacking or defending on the queen side or the king side. From white's perspective, the queen side is on the left here. So files A through D are the queen side, and then E through H are the king side. And then we have center files defined. Hey, Alvaro, you haven't missed much. I'm just going through what I've updated in the notebook so far, mostly just related to the bitboards. And that reminds me, I should just open up what we have here. And we can take a look at the code in a moment. So we have ways to talk about the queen side and the king side in terms of bitboards, and the center squares, which we can get just by, well, we can look at how we can get that, but we can mask and basically do a logical and on like the center ranks and the center files. We can take a look at that. And then the flanks are the A and H files. We have ways now also of moving in the various directions. And when I was reading the chess programming wiki, when we talk about, let's see if we can find it. It's maybe in board representation, move generation. It's going to be like ray, like they called it a ray. Ray attacks. So sliding pieces, yeah, not X-ray attacks, but so X-ray attacks is a chess term, but sliding piece attacks would be, I'm really trying to find the article that this came from. By the way, this website, this chess programming wiki is pretty incredible. It's just a little scattered. The information's kind of scattered all over the place and written by a lot of different authors. And so sometimes, like, my task so far has really just been to sort of try to synthesize all this information. Here we go. So on an empty board, we define these ray attacks. And if you think about it in terms of a bitboard, so we have a one-dimensional numpy array that represents the entire, any given bitboard. And so when we think about motion in one of the sort of cardinal directions, we add or subtract some number of values. So if we want to go east, then we're just plus equaling 1. If we want to go west, it's -1. But then likewise, if we want to go north, obviously we're adding 8. And then, or we're adding the square root of whatever we're adding the length of the board, effectively, the square board. Northeast would be +9, northwest would be +7, and then -9 and -7, -8 for the south directions. So they give a little example here. There's some square mapping considerations that they give. Okay, so that's been implemented. So now when we call +1 on any given bitboard with input as a square, we move in that direction to the end of the board. So in this way we can kind of like project the sliding piece motion. And so I anticipate us being able to do things like when we reach, say, another piece, and we cut off that ray, and we know that we can, the legal squares for that given piece, in this case that's on F4, in the diagonal direction. So let's say we have a bishop here, and let's say there's a black pawn on C7, then we would need to determine that this ray intersects with C7, and we could do that with a bitwise AND, I suppose. And from that information, we'd be able to see whether or not that particular move was a capture. But it's going to be interesting because we're going to need to take the bitboard from white side and AND it with black side's piece position to determine that that's a capture. If we AND on 2 white side bitboards, then that's just an illegal move because we can't move a bishop into one of our own pieces. So that'll also help us understand how far a particular piece can move in any direction. So yeah, just playing around with the other directions. There's +8. We had to do some things to make sure that pieces didn't wrap. So you'll see each of the different methods in here: +9, +8, +7. And I know none of this is like particularly efficient, but we're just doing for I in some particular range, making the index in the bitboard at that position hot, and then in most cases, if not mod 8, then returning so that we don't overlap on the board. So I think all of the directions are working. Then I played around with making knight attack bitboards. So a lot of this bitboard stuff is still pretty new, or completely new to me, and so I'm still kind of wrapping my head around how a lot of this is going to be used. I get, like, intuitively, I get the intuition that being able to do logical operations against sets of bitboards is really useful. It means we don't have to do a lot of looping. If we can just do set operations on things like and, or, XOR, not, we don't have to loop. And so I think and bitboards themselves, it can be really dense in terms of the amount of information they can encode. Anak is saying, play chess with me. You're rated 450. Okay. If anyone wants to play chess, I forgot to mention that. While we're doing this series, I figured I would also throw it out there. Just challenge me on Lee Chess at Westman, or if you're on chess.com, I'm West Doyle on chess.com. Okay. Yes, by all means, throw a challenge up, and hopefully I'll see it. So we have these knight bitboards. What I was reading about piece-centric notation and board representation, not using bitboards, we use like the mailbox paradigm. I think what's done in many cases is to create squares outside of the board, like 2 squares around the border, so that it's really easy to determine what's an illegal knight move without wrapping. In the case for what I've written, since we're using bitboards, I basically just had to create a bit mask on the side that would overlap for the night. So if the night is on like H1 in this case, it's going to be overlapping in the array, in the numpy array, for its moves, which would otherwise be on the board if the night were more centralized. And so all I have to do is say, whenever we're on the G or H files here, then I'm going to put a bit mask over on the other side of the board, and then we can apply a right shift on, here I'll show, let's just go to it. So what do we do when we need to know if the knight's attacking a place? All right, so the way the night attack works is I set a row and a call mask. By the way, once again, I'm pretty sure that this is not efficient at all, but I set a row mask and a call mask and an aggregate mask, which is just going to be the logical OR of the rows and column masks. And the rows and columns masks in the case of the night attacks here are going to be A and B, G and H, and then the ranks 1 and 2 and 7 and 8. All right, so then if the square that we're on is on the A file, then the column mask is going to be G and H. If it's on A, sorry. If it's on B, then the column mask is going to be G. So this is saying that if the knight's on A, then we need to mask off G and H so that they don't overflow. And then, good call, Alvaro. Actually, Alvaro almost beat me yesterday, or the day before, whenever that was. Those were some good games, so thanks for the games. And hopefully we'll play again sometime. If you, Anak, if you do want to play, I think you can come up here and then click this plus button. And then let's see how you would do this. You would do real time and then choose like 5 minutes or 3 minutes, something like that. And looks like maybe you have to, actually, you know what? I'm not exactly sure. Oh, yeah, there we go. Click this, and then you can click, you can type in Westman here, which would be my name, or if you know what your username is, I'll send you a challenge. All right, so if our knight is on A, the A file, then we need to mask off G and H so it doesn't overflow. So we just logical OR G and H and set that as our call mask. If it's on B, then the furthest the knight could jump and wrap is to the H file, and so we just mask H. So I think that that's actually a, yeah, that's a bug, I think. So this, and then if you're on G or H, likewise, you have to mask off either A or A and B. There's an overflow for the ranks, which only happens if we're on the first or second rank that we don't overflow. Okay, sum the masks just with the logical OR, and then make this attacks bitmap. And so a knight's attacks from any given square are these, +0, which is the square the knight's on, and then in every direction, up 1 and over 2, or up 2 and over 1. So those are the 8 other squares besides the squares on that the knight attacks. If we're out of bounds when we do that sum, then we just continue. Otherwise, we turn on one of the attack squares. And if we have a mask, then we right shift the attacks by the aggregate mask. These are just 1s, and so they'll turn into 0s when we do a right shift. Then we return attacks. So that's the knight. And now we can do some fun stuff with the bit masks at this point. Basically, we can answer questions like, what piece does a white knight on f5 attack if black is in the starting position? We can just do bitwise and, or yeah, logical and of the knight bitboard when the knight is on f5, which is in the question, and we AND that with the black pieces bitboard, which in this position are just in the starting position. So in return, we get the bitboard with one hot only where the only on the squares that the knight attacks. So we can do this, and that's just a numpy array, and we can see the two ones. I'm pretty sure that we have a few too many bitboards. So I'll keep an analysis board open as well, just in case we want to talk about it or about chess. I was looking at a few other engines yesterday as well. So the most famous chess engine these days, the most famous sort of like consumer chess engine that's not AlphaZero, which is famous for other reasons, is probably Stockfish. And it is an open source chess engine. It's very strong. The chess engine rankings are at, I think, LLRC, not LLRC, chess engine rankings, CCRL. So I'm not really sure what this Shash chess is, but that's amazing. And where is Stockfish? Why isn't Stockfish on this list? Stockfish should be the top. Did it change its name or something? So I'm not sure why Stockfish isn't on that list. It should be. But anyway, here's Stockfish. It's open source, and you can take a look at the GitHub repository. The chess engine that we're building here will not even remotely approach the sophistication of Stockfish anytime soon or ever, but this is an example of a really good chess engine. There are some others out there that are pretty popular. Like, there are a ton of others. Shredder, Houdini, Leela, LC0. But if you poke around on Stockfish source code, you can take a look at some of the Bitboard files they have. So here are some sliding attacks, which you can see. Yeah, Anak mentions Komodo, another really good chess engine. We look at the Bitboard header file. We can see, first of all, this is written in C, and so it's going to be much, quite a bit lower level than what we're working with here. But we can see that there are different bitboards here for ranks and files. They have a queen side, center files, king side, and center as well. So you can see I'm doing my center bitboard in just the same way, where here we're doing a logical OR between the D and E files and the 4th and 5th ranks. So we can do that in very much the similar way by taking the C and D, or sorry, we got center, E and D, and ANDing that with the OR of the rank, the 4th and 5th rank. Okay. So I think what I'd like to move on today is the actual game itself. There's still a lot more to do with bitboard representation, and we're also going to need a way to keep track of what actual pieces are on each of those squares. Yeah, Anik, if you send me your username, I'd be happy to challenge you as well here. Otherwise, my username is Westman, and you can throw it in the challenge. But yeah, happy to play, especially in between figuring out some of the things that we want to get done. So I've got an empty game class. I've got a position class, and the way that I was thinking about representing a chess position was with the board, of course, the board representation, which will be where white pieces are and where black pieces are. So we can do a logical OR on white and black bitboards. And then the current side to move. And then we also need to track castle rights on passant target and the half move clock. So we have to track these because technically what's possible in any given chess position isn't a matter only of the state of the pieces, but it's also has to take into account the history of the rest of the game up until the last non-reversible move. And that's because we can show that here. Like we could reach a position like this, and basically repeat positions. So this position happened here on move 2, but it also happened here on move 5. And if we were to repeat this position 3 times, then it would be a draw. So either side could claim a draw if you repeat a position 3 times. But if we were only given the state of the pieces, we wouldn't know if we had moved 3 times or not. So we need some history up until the last non-reversible move, which would be something like pushing a pawn, for instance. So we can't, pawns only move in one direction, so we can't, we don't need to know anything past the last non-reversible move. It's also true, that's also why we need to know what the half move clock is. So we need to know when, say, like the last pawn move happened. Half move clock. Yes, so this is for the 50 move rule. So if you move 50 times without, and a move counts as a white move and a black move. So if there have been 50 moves in which a pawn hasn't moved or a piece hasn't been captured, then that's another way to claim a draw. So we need to know that information. And then en passant target, we need to know as well, because we could get into a position where, let's say that we want to start thinking about en passant. I'm just going to play some completely non-realistic moves. All right, so if black plays like this, so now the target en passant square here is c6. So we can play c6 here and capture black's pawn en passant. But if black had moved one square up, then we moved here, and then black moved here again, we can no longer en passant on c6. So we can only do en passant after black has moved 2 squares forward. And so if we were to see this position, we would need to know if black had just moved from c7 to c5 or c6 and c5. And then, so that implies that we also need to know some history here, and we can use that en passant target at the time that it happens to know whether or not we can take on the en passant square. And Alvaro asks, don't we need to have the stack of moves? And so yeah, so that's correct. So I think that the way I'm going to write this is basically the game itself will be a stack of positions. And that's right, Alvaro. So if the same position has repeated 3 times, it is a draw. Or one player can claim a draw. Okay, so that is the general idea. So I found another good article here, if we could find this, hash moves, piece lists. Let's see. So here's some other good questions that we need to answer. How are we going to track what piece is at each location? Now that we have these bitboards, how do we distinguish between white and black? How do we distinguish between captures and normal moves? For that, we should be able to AND the black and white bitboards, like a white attack bitboard with the other side's pieces. Yes, Alvaro, I believe that's a really good point, and that's correct. We need to know specifically, I think it's usually represented as the target square. So which will tell you whatever it's going to be the square behind whatever pawn can be captured with en passant, I presume. That's a good point. So when we look at the position, the en passant target here will have to be the target square. And if I'm thinking about it, let's do this. Yes, it's only ever one square. So for instance, I couldn't en passant here on e6, but I could on g6. However, I could, for instance, en passant with more than one piece, but it's still the same target square. So here I could en passant with h or with f. But again, it's whatever square the last moved piece pushed over, slid over, as if it had just moved here. The difference is once it moves here, as white in this case, we only have one turn on which we can capture en passant. So if we don't capture and then black makes another move, we can't en passant now. Okay. And then in terms of the game, self.history is going to be a stack of these position objects. At least that's the idea. We could prune up to the last half move, or the last, what's it called? Yeah, the last half move. The last non-reversible half move. But I'm not going to do any type of optimization at all until we actually get something that kind of halfway works. So, all right. So let's see if we can keep a way to keep track of the pieces and what squares they're actually on. So what's going to happen is white makes a move, and then we're going to update all of the bitboards that we're tracking. And like I said, I think I'm tracking too many bitboards right now. Oh, and that's another point. There's there's a distinction between types of bitboards actually. So yeah, right. So like some bitboards are sort of these global static bitboards that can always be used to check that never change. So things like the center squares or the bitboards for each of the ranks and files. Those are completely static and global. They never change throughout the course of the game, but they might be ANDed or ORed. They might be combined in logical ways with dynamic bitboards, which might be things like the bitboards for all of the squares that a particular piece attacks. Likewise, the knight bitboard is a static bitboard. The knight attacks bitboard, we just compute that at the start of the game, and then whenever we have a knight on any square, we can access the bitboard for that square without regenerating it. So we just generate 64 bitboards for the knight. All right, so that's the difference between the static bitboards, which we don't need to update. There's no reason to update the knight attack bitboard because a knight on any one of the 64 squares always attacks the same other squares. But we will want to update the bitboards for white's pieces, black's pieces, and then probably the attacked squares for either side. So let's see if we can get something like that started. So where should this one go? So the board is really about the bitboards at the moment. Position is, this board is going to be a sum of the piece bitboards, I think. So logical OR. Side to move is obviously going to flip each move. we're going to need to make a move. Self.move equals not self.toMove. And this to move is just a constant. It's going to be 0 or 1. We could make this true or false, but in Python, the true and false are 0 and 1, so that works. Oh yeah, the one with George Hotz. I watched that a while ago, like maybe a year ago or so. It's a little while. It's been a little while since I watched that live stream of his, but it's really interesting. And I think he uses PyChess. Maybe I believe he was doing more of a. Was he not like trying to do training on a chess engine with neural nets? This is going to be totally heuristic based and from scratch without PyChess. I should probably read PyChess to look at how it's been done previously. This is mostly just for me to sort of learn the basics of chess programming. But yeah, GeoHotz is a great channel. All right, so we switch the sides to move. We're going to update bitboards. So the move should be input as a string. We could check to see if it's a legal move. So if not, is legal move. Print. So how's this going to work? Basically, the root bitboards are the piece boards for either side. So we have sort of class boards for the rooks, kings, bishops, pawn, knight, and queen. When we set up the starting position, we call init pieces. We set white and we set black. So we just index into the relevant bitboard for the piece and turn that square on. So when we move a class of piece, do we just wipe out the bitboard for that piece and then turn back on? It would be nice if we just wiped out the specific index that the piece was on, turn that to 0, and then update the new index to wherever the piece landed to 1. All right, so what is the syntax for a move going to look like? I'd like to keep a bitmap of the legal moves as well. And that can be done by looping through legal moves for, oh, that's tricky. I'm still wrapping my head around move generation with bitboards and bitmaps. All right, so let's say that the syntax for a move will look like this. Probably don't need an initializer. This is basically just going to be a class that takes, or that has some sort of static values on it. So like all of the pawn moves, so pawn d to e4. I want to have like a parsable syntax. It's like really easy to serialize and unpack. So pawn from square to square. If a legal move, you have to return to the acting side as you are undoing the move. Also, the input is the new bitmap of the moving piece. Yeah, so actually for this one, yeah, I haven't completely worked it out myself yet either, but we're gonna check if it's an illegal move. And then I don't know how this is gonna return yet, but yeah, we're not able to move past this section before we update the bitboards and then ultimately change the side to move. And then as the input, is it the new bitmap of the moving piece? So what I'd like to do is to provide a command to move the piece, check whether or not it's illegal, which we can probably do with the bitmap, which we can do somehow. But I'm not going to be passing in the bitmap as the command. Rather, I'm going to have a command that I then provide to the board, and the board will update the bitmaps accordingly. So let me go back to position, move. I'm just thinking like what this syntax looks like. So D to E, pawn, D3, D4. It's not going to be scalable because there's like a trillion moves for say like the every bishop move, every every knight move. So how do we provide a command? I'm also going to grab my chair real quick. All right, so the question is how are we going to provide a command given that we have some board object? Let's look at the wiki really quickly. We can head over into move generation. Yeah, they're not checked before to see if they leave the king in check for pseudo-legal move generation. It's left up to the move making function. Make moves a function inside a chess program to update the internal chess position and its board representation, as well as associated, or I'm going to try to make this a little bit easier to read for myself. That usually happens inside the search algorithm, where the move acts like an edge connecting two nodes of the search tree. Yeah, we're not near search yet. The general arithmetical and or bitwise logical operations to convert a node to its child are either reversible by inverse, addition or subtraction, or own inverse, XOR operations, or are irreversible. For instance, a sequence of addition and conjunction of move aspects. Man, this is where, yeah, it's already kind of getting a little bit difficult to understand. Aspects of a position are altered by reversible operations may be kept in global structures. Encoding moves, this is kind of what I'm wondering about. From and to based. Okay, that's interesting. The information required to uniquely describe a move is the initial square, also called the from, origin or departure square, and the target square, also called the destination square, and in the case of promotions, the promoted piece code. While this from to information is also sufficient for castling, due to otherwise impossible double king step, it might not in chess 960. Well, luckily we're not coding for chess 960. Therefore, and also for efficiency reasons, castles are tagged as special moves. Such a move encoding conveniently fits inside a 16-bit word. So we have a bitmap for attacked squares, or we can build a bitmap for attacked squares. We know the rules of motion for any given piece. So we just need the from and the to for a particular piece. And I'm going to ignore castling right now and promotion until we get some of the basic stuff worked out. Move can be described by the moving piece code and destination square. In case of disambiguating moves, if two or more identical pieces can move to the same square, the file of departure or files are identical as well, the rank. So that's like if a rook, what they're talking about there is you can have positions like, let's just play and get a bunch of pieces out. All right, now I'm just going to move a bunch of pieces off the back rank to illustrate. All right, so here, if we just said rook to d1, you'd have to specify the files. You'd have to say rook a to d1 or rook f to d1, and we can see that in the PGN syntax as well. So rook f to d1 or rook a to d1. And then in the case, let's say we had two white queens, and the queens were sharing the same diagonal, like we had a queen on a6 and a queen on e2, and we wanted to move queen e2 to c4, we'd have to say queen e2 c4 versus queen a6 c4, which would be a lot more rare than the connected rooks example. Okay. So yeah, I guess I can close the Stockfish source now. They also use something called magic bitboards in Stockfish, which I haven't researched yet. All right, so really we have piece from 2. And then we also need to know, is it a capture? The other examples were is promotion. And then what they said earlier was like, if it is a promotion, you need to know, like, you can provide some subsequent information about the piece that you're promoting to. So if a pawn makes it to the other side of the board, so if a white pawn makes it to the H rank, then it can promote to a queen typically, or it can do what's called under promotion, which would be promoting to a minor piece or a rook. So if it is promotion, here we're going to have to get the promotion type somehow. All right, so we want to make a move. And then update the bitboards. The legal move check will basically be checking for the particular piece type whether or not it ands with that piece class bitboard for attack squares. But that's not totally sufficient because it's piece classes. So if we have 2 rooks, we can't just say so the bitboard for attack squares for white bishops in this case is the diagonal from a4 to e8 and the diagonal from a6 down to f1. The black bishop is this other diagonal on dark squares. And so I can't just say that the bishop on b5 has a legal move to, say, f4, which would happen if I just anded the attack bitboards of the white bishops with my target move square. So it's not the attack squares for the piece classes, it's the attack squares for the piece. Okay, let's keep track of where all of our pieces are. I think just by hacking at this and filling out the parts that it feels like we need, eventually there'll be a lot of optimization happening. So let's start with piece map is this dictionary we'll call get piece, I don't know, basically we're going to set self.piecemap. We can store this for now as a dictionary. Because they have all the squares encoded, so that will easily convert to usage in a bitmaps that we already have. And then I have constants for each of the pieces. I feel like we need constants for each of the individual pieces, but now I'm even confused about, like, let's say you promote, then a pawn turns into a second queen or a third queen or something. How do we represent that? That's thinking too far ahead, but it's also the case that we don't need to track individual pieces. I keep coming back to this in my own head. We just need to know the rules of motion for any given piece. Put it into the piece map in the position. So back in the position, piece should map from piece to square. No, it needs to map from square to piece because we're doing square centric. And I already did all this work in the board to place. I feel like now I want to build the piece map over here on the board, but I need to be able to update it from the position class. All right, well, here's what I'm going to try. This is a little bit janky. In my position, when I want to track stuff, here's what I'm going to do. The piece map I'm thinking of as a dictionary where every key is every square, and then every value is a particular piece value or the empty piece. So import color. Piece. And I'm just going to split this here. And then we'll go back to editing the position. All right, so I'm going to set the initial piece locations. So self.pieceMap is now a piece that isn't piece imported? No. Piece.blackbond. It's so hard to switch your brain from thinking piece-centric to piece-centric to square-centric. Speaking for myself, anyway. All right, so and then it's Orion range 1 to 8. Also, I always forget this. We need to go back to Jupyter for this. So we got a white rook on A1 and A8. Anton is asking, is there going to be a .NET Core 5 project series? Yes, there is. And Alvaro, for sewing samples, I think the board editor will be easier. Yeah. If you mean the like the analysis board, definitely. Thanks, Beast. And Anton, yes, to answer your question about that, there is. And I can pull that up really quickly, not to get distracted from what we're doing here. Long story short, yes, I have finished a .NET Core or a .NET 5 web API for a CMS, and I'll be releasing a YouTube series for that, and then an extended series on Udemy for that, which will involve some more things involving deployment and image uploads to S3 and things like that. But there'll be a YouTube series and then a deeper dive in a Udemy course. And my goal is to get that out before the end of the year. So that's the only other project I have going on besides this one. So this live stream I'm doing just for fun because I've always wanted to build a chess engine, and yes, I'm just giving it a shot. All right, white rooks are on A1 and A8. Or sorry, yeah, A1 and H1. So we got those. We can put the knights on. White knight. Also, WN is knight because WK is king. And the king stay the king for anybody who's watched The Wire. All right, so knight, knight. 2-5 are our bishops. And then 3-4 are queen and king. White queen. 4 is white king. All right, I don't need the other one open anymore, I don't think. So we place the white pieces. And then it's going to be up to the position class that we have here to then subsequently update the bitboards. So like if a promotion happens and there's a new, I don't know, a new black promotes to a new queen, then we insert the queen into the piece map, and the piece map gets translated to update all the relevant bitboards, including the attacks and the positional bitboards. All right. Oh, I know why I needed it open. I wanted it open for the other side. $48, $56. Black rooks are on 63, 56. Black knights are on 57, 62. Black bishops are on Thank you. Good call, Alvaro. Good catch. Thank you. All right, so 62. I love this ability to pair program. All right, so we now need the bishops, which are going to be on 61 and 58. So 58 and 61. Queen is on 59. King is on 60. All right. So now we've got this piece map. So already we have kind of a hybrid approach. The bitmaps will be used for easily determining what pieces can move where and how they attack. Also for more things that may be useful in evaluating the position later once we get to writing the search. So things like queen side, king side. I'll probably move this pretty print out into its own module, like a debugging module. Hey Shanawaz, Khan. All right. So the bitmaps will be used. We have this hybrid approach kind of going on. The bitmaps are used for everything that we've seen them used for here. So we don't need to loop now with the vector addition, or the whatever you want to call it, the bitwise addition with the various bitmaps. There's no looping done to actually determine what squares are attacked by a particular piece. So to determine anywhere a knight can move, there's no looping. This is actually just static. This is just a direct lookup because the knight, it's this particular bitmap is defined for any given square at the start of the game. So that's good. And then these sliding piece bitmaps, again, there's no need to I'll have to think about the sliding pieces more actually. But then we have some other bitmaps which could be useful for positional evaluation later, which we're still quite a ways away from. The idea is once we make our move, we have our piece maps in position. When we make a move, piece map gets updated for the particular piece with a from square and a to square, and then some additional data if it's a promotion. We can then update the occupied squares. From these occupied squares, basically lots of other information can be calculated, like what squares are attacked now, and that sort of thing. I read this thing by John, not John, what's his name? If we go back to the main page, and then the Bitboard page, I spent a lot of time reading this article, yeah, by Bob Hyatt, Robert Hyatt. Let's try to find his webpage. Yes, Alvaro, I think that's the idea, although I'm almost certain that I haven't done things like as efficiently as I could. I'm trying to find the reference that Bob Hyatt gives to that and that we're kind of bringing up here, which is that there's a lot of sort of parallel information, if you will, like parallel. There's more than one question that can be answered at a time with bitboards just by doing this bitwise, just by doing bitwise operations on two bitboards. So even just to answer questions like, oh, here, by the way, this is part of the CMS that I'm building with .NET Core for Anten, who asked earlier. Um, to answer questions like, what pieces does this knight attack? So there's a knight on F5 in this position. What white pieces, or what black pieces in this case, does the white knight on F5 attack? There's no looping done here at all. It's just instant. It's just it's an O of 1 in this case, big O of 1, constant time lookup, because it's just a single logical operation between two bitmaps that already exist. The bitmap for the black pieces and the bitmap for the squares that the knight attacks. So it's not like we have to loop through all of the squares on the board and then do an AND at runtime, if you will, to locate them. We just do the conjunction of the knight bitboard with the black pieces bitboard. But it still hasn't completely sunk in for me about the sliding piece bitboards, which I have these -7, -1, -6, -9 bitboards. So I'm trying to find the Robert Hyatt article about that. And Bob Hyatt, or Robert Hyatt, is the guy who invented or wrote Crafty, which is another chess engine, an older chess engine at this point. But I gotta find his webpage. Yeah, here we go. It's like totally plain text, but this was what helped me understand bitmaps. And it wasn't even this one. This was the second one. The first one was board representation.html or board rep.html. This is another type of representation that's not bitboards, this OX88 representation. So this is what I was remembering that he said in terms of asking more than one question and answering more than one question in a single operation. So one additional advantage to bitmaps I've come to call bit parallel operations. A simple example illustrates the idea best. We're trying to determine if the white pawn on the square e4 is passed. So a passed pawn is, I'm not going to be able to draw up the position really super quickly. Let's do this. Let's do this, this, this. Um, all right. Well, the white pawn here is passed. This, yeah, okay. So it doesn't have any contenders up the board. So if you want to answer the question as to whether or not the e4 pawn is passed, you have to check the squares d5, d6, d7, e5, e6, e7, f5, f6, and f7. So if you look at that, that's going to be, we're on e5 instead of e4, but it's going to check if there are pawns anywhere that could capture this pawn. So it's passed if it can make it all the way up the board without the threat of an opposing pawn capturing it or blocking it. So normally you'd have to check all of those squares to see if they're occupied by black pawns. With the offset board representation, that's another one that's not bitboards, we'll either have to test each of these 9 squares one at a time or else incrementally maintain the status of each pawn as to whether or not it's passed, which you'll see later is going to complicate make move in a significant way. Using bitmaps makes this not only easy but actually trivial and fast. We simply pre-compute an array of 64 bitmaps, one for each valid square a pawn can occupy, plus the 16 squares where a pawn will never exist. That's the first and 8th rank. For the bitmap for square 28, which is E4, we simply set bits for the 9 squares listed and save this bitmap for use anytime we want to ask whether the white pawn on E4 is passed. To answer the question, we simply AND this bitmap with the locations of all black pawns. And if there's any hot bit in that bitmap after the resulting bitmap after the AND, then you know that the pawn's not passed. So the way that would look in our example is, again, maybe it's best illustrated with this. If we had a bitmap and he's saying like store as a bitmap all of the squares, like in this case, d6, e6, f6, d7, e7, f7, you store that as a bitmap. That's sort of the past pawn squares bitmap for the pawn on e6 in this, e5 in this case. If you were to do a bitwise AND of those squares and the result came back as having any one in it whatsoever, which we could do in NumPy really easily with .any on the NumPy array, then we would know the pawn isn't passed. So if there was a pawn here, for instance, on e7 or on f6 or whatever, and we did a bitwise AND with these 6 squares here, we would get 1 because we would have f6 as 1, and then we would know that this pawn isn't passed. Whereas if we weren't using a bitboard representation, we'd have to do one of 2 things: either loop through every possible square that a pawn could be in and check it, or he's saying, I guess we could store some data on the pawn object itself to determine whether or not it's passed and then update that ahead of time. So I don't see how that's any different between looping, but so I get his point here. And then he's like, if bitmaps are so great, why isn't everyone using them? And he said at the time this was written, which may be like in the 90s, that it was speed of computation at the time. And he talks about 32-bit registers for AND or XOR and similar operations. This doesn't hurt much, but for shifting, and more importantly, finding the first 1 bit that's set, current machines don't offer any features to make this, blah, 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 blah. Okay, this was written in 2004. And if you read about what other chess engines are using, most of them use this hybrid approach with bitmaps used as well as piece lists. How can I avoid looping to initialize the bitmap? Just a moment. This one gave me some hope since I still don't understand bitmaps totally. At least Robert Hyatt says that it took him a year before he was able to get past the mental gymnastics of designing an algorithm using offset representations, and after 2 years of working with and make what he had fit the bitmap approach. So he had to sort of like unteach himself the offset methods, and luckily I'm kind of starting with the bitmap approach. So with regards to hotspots of the potential competing pawns, so I think the idea is I can always define a bitmap for past pawns. Like, can I click on this and highlight squares? I think on chess.com I can. Let's use chess.com analysis board. So my thought is that if we're concerned with past pawns, now he said one bitboard for every square. I was thinking about this a little bit differently, so I'm going to give it my best shot at explaining what he means, but it might be wrong. So my thought was if we wanted to know past pawns, we could store a bitmap for any given pawn that gets updated if a pawn gets moved. And I have no, okay, here we go. Wow. Mouse skills. Thanks. So I have my trackpad, which isn't that great at right clicking. All right, so my thought is, let's say that the pawn is the pawn on e2. We update this bitmap anytime the pawn moves. And if we ever want to ask the question if this pawn, by updating this bitmap, now this is a good question. So I was going to say we just have the bitmap, right? And if we see the bitmap for a pawn is always going to go up to the 7th rank, or if it were black, up to the 2nd rank. And in this case, if we were to AND what we see in the black position with this bitmap in green that we've made for this particular pawn, definitely we get 1, obviously, because we're overlapping with 3 pieces on the black side. And that tells us that this pawn isn't passed. Now the question is, how is this different than looping over all of the squares? So I was going to say this bitmap always exists, right? Like we could initialize these bitmaps for every pawn at the beginning of the game. But they need to change after every move because I could have like trying to make a example. All right, so we have this position. And if we had that original bitmap for this pawn, which just looks like this. Oops. But here's the original bitmap, and if we never updated it, even though this pawn is a passed pawn, it would come back as not passed because the 2 black pawns are still in the bitmap. And then, yeah, I think maybe you're right. Maybe the updating of the bitmap is still O of n squares. Luckily, we only have 64 squares. But yeah, I think you're right. Let's say we update the bitmap to look like this. It's not O of n though, right? Because for any given pawn move, it's just two slices. Wait, it's just the number of slices that there are rows left. It's gonna look like on the first one, I don't know what the squares are, but it'll be like 12, 13, 14. And then plus 8, right? Like 20, 21, 22. I don't know. All right. Yeah. I should probably focus on the getting our piece list put together, but I still have so much to learn about this Bitboard thing and optimizing everything. It's fun to draw on the board though. Someday we'll have a GUI for this thing and the actual thing running on the back end. That would be pretty sweet. All right, so come back here. All right. So we set up our pieces. We have a piece map. Should play with this in Jupyter now. So we can set up a position. A game is going to be a stack of positions. Yeah. Yep. All done with that one. I have no idea. Get next move. I'd like to be able to access this. Take back move. This would be self.history.pop, right? What does Python return for this? So let's say we have a couple of things. So 3 was the last thing that went in. If I call x.pop again, does it mutate the list? It does mutate the list. So if we have x has 1 left, and then if we x.pop, and then if we x.pop, this should throw a key error maybe. Index error, I mean. Yeah, sorry, index error. All right. So if our game history is a stack of position objects and we want to take a move back, we just pop the last position off of the history. If we want to get the last move, I should say get last position. We want to return self.history -1, right? Get the current position. So we're going to do like x.append 4. -1 will get us 4, -2 will get us the position before it. Def add position. Self.push. position. I'm just going to kind of hack things together for the moment. All right, so from position, import position. Initial position is equal to a new position, and then we'll self.history.push initial position. Yeah, thanks. I had to get my brain back in Python mode. All right, so get last position. That would be an index error too, right? If I did like this, or would this just loop? Yeah, index error. All right. Sorry. All right, so we have a way to push and pop positions off of the game history stack. Self.history.push initial position. We new up the initial position. Add position. Oh yeah, what am I doing? Self.history.push. And not worried about this for the time being. Self.history.push position. And I'm not gonna hide that. So we'll blow up in the get current position and the get last position, take back move. All right, so now if we look back at the position, we make, when a new position is initialized, I'm trying to figure out if I want the position to have access to the bitboards or if I want the bitboards to have access to the position. So maybe the position is what we work with. The bitboards are, no, I just want the relevant bitboards on the position and then make position control updating the state of the bitboards. I think so. So what bitboards do I want? Is this all one class? Board. So I guess I kind of like that. Self.board is a board. except that we're going to have as many positions as we do half moves in the game, and that's a whole lot of state. So I think I want a lightweight board which just has the dynamic position information, and all of that static bitboard data, like the knight moves, the center of the board, the each of the ranks and files, that's like global. That should be a singleton because it's just used for calculation purposes. It doesn't make any sense to keep that in the whole stack of actual game positions. So the stack of game positions should actually only ever keep the bitboards for the white pieces and the black pieces. So the logical OR for all of white's piece sets and all of black's piece sets. Because from that information, we have enough information to determine how many moves have been made, which takes care of the 50 move rule. We have enough information to determine if a position has been seen more than 3 times or been seen 3 times. So I think that I want a lightweight board object for this. So something like board dot I was thinking about having a static method on it that's like board dot get piece positions. And then I have no idea what search is going to look like, but whatever algorithms are used to do search could reference not only the static stuff on board, like the knight attack squares and the center and all the other things that could be used for evaluation, but also the attack squares of any other piece, which I just said knight, so I'm not sure. All right. So let me step back to position. Sorry, to game. We have a stack of position objects. Game is just concerned with tracking the state of pieces over time and pushing or popping from that stack depending on whether we're making a move or taking a move back. There'll also be a way to get a move. there will be a self.move number. All right, thinking. All right, I'm gonna play a quick game of chess. As a break. All right, e4. We'll play another Italian game. I think played a couple of these. All right, so now there is sort of slightly risky opening I can play with knight g5. Normally they play d4 takes. If he plays knight takes, okay, so this is the sort of main line. There's a nice trap in this line called the fried liver attack. That did not happen, so his knight's pretty short on squares. And the knight on a5. Although now if I play b4, he has a spot on the knight for the knight on b7. So I'm just going to develop. If I play castles, I'm a little bit worried about g5. So in fact, I'm going to try to pose a question to the bishop that he just placed on c5. Maybe he plays just bishop d6. Okay. So if I play queen e2, preparing to castle queenside and attacking the pawn on e5, I want to get my king to safety. So I'm going to go for this. Yep, so he castles. So I'm trying to figure out if the pawn on e5 is really hanging. So knight takes, he can just play rook e8. So I'm going to go with my plan and castle queenside. So if takes, takes, Takes knight d4 with the idea of trying to play knight e6. I'll probably take with the knight in that case. I'll still play knight d4. Yeah, so he takes with the knight. Okay, so does he want to give an exchange sack? An exchange sack is when you trade a rook for a knight. He doesn't. I really want to keep this bishop, but I'm not sure if I can. Okay, I do have to make a move here soon. So I'm going to attack here. Yes, Alvaro, I will push. Also, David, good to see you. Thanks for stopping by, Alvaro. Catch you next time. After this game, I'll head back to working on it for a little while longer. Probably work until about 8 here, 8 p.m. So another half hour after this game. So I'm threatening the pawn on f5, I think. I suspect he'll try something like g6. So he's just going to attack this knight, which is probably a good idea. So what's his idea? Can I just take here? Okay, so he's trading another piece. No forks, I don't think. So what's his idea now? He's just going to take and win the pawn back, I guess. So knight takes e6, e takes e6, queen takes e6, queen takes e6, rook takes e6. After that, I have rook d7. Rook d7, rook c8, rook hd1, king somewhere. He can also play knight takes. So I think it's going to go knight takes. Knight takes e6, d takes e6. Oh, and he doesn't. Okay, then I think I can play like this. I can force the trade of queens. Almost out of time. So I didn't force the trade of queens. I wish I had more time, but I'm up 2 pawns. This does not win because I can block, my friend. Good game. All right. So let us figure out now how I want to keep a lightweight bitboard attached to each position. So the idea was to make a static method get position, not a static method. Thought about making like a factory to make a new bitboard from the existing, which doesn't make any sense. I just want black pieces and white pieces. So it's almost like I want this bitboard class to be a service which can give me state at any given time. I can use it to query against. But in terms of the position, I don't think I want a bitboard pushed into every position. So every position is going on the game stack. I won the game, Alvaro, but I'm losing the game of building a chess engine. So the thought was, if I'm wiping out the bitboard every time and I'm sending a new piece map to bitboard like a service, almost like a bitboard service, if you will, that can return the position bitboard. It's like I want the bitboard thing to behave. I'm thinking of it like a web developer. I want the bitboard class to sort of be this service instance, if you will, to which I can feed a piece map and it returns me bitboards that I can use. But I don't want the whole bitboard. I don't want an instance of a bitboard in the position object. Bitboard or board class, I should say. Because that thing contains a lot of data that's really just used for runtime calculations. I just want a data structure, which is a bitboard, but not a board class itself. So right now in the code, I'm working on the position class, and I'm trying to figure out how I want to collaborate with the board object. And what I'm thinking is, rather than have an instance of a board, I'm thinking of the board class itself as I'm conceiving of it like it's a service. Like I want to be able to query it, but I don't want multiple instances of it to exist. Because a lot of the data that's on it right now, it's just sort of bloated. It has like static bitboards. It's got the pretty print bitboard function in it. So I just want to be able to feed it something like a piece map and get back the position bitboards. So that's what I'm going to do now. So I'm going to make a static method or a function that says get or build position bitboard for a given piece map. I'll separate this out. I'll separate this out later. For now, we're going to have an instance of a board class. It's just too bloated, but it's basically doing too much and keeping too much state. I want to separate out the state that's like global board state and then the state that just represents the positions of pieces, which is the bitmap itself. The FEN, yes, exactly. Basically, actually, you know what? That's a really good point. All we need on the stack is the FEN. Just the static encoded positions of the pieces, the castling state, the en passant, target square, and whose turn it is. Yep. And for right now, in the hacky version that I'm making right now, I'm going to put a whole board class on there as an instance. So when we initialize it, we're going to create a board. I have a default board size of 8, but technically I think I wrote most of the functions on here, most of the methods to support other board sizes for what it's worth. So we're going to put a new board into every position, which I know is not good because I'm putting the positions on the stack. I guess that's the other thing I could do is I can have the positions generate an FEN, and then we put the FENs on the stack. I think that's probably a good idea. We can make this to do generate FEN for the current state. This will be like self.board.update, and we're going to pass this self.piecemap. Actually, that's a really good thought, Alvaro. So thank you for throwing that idea out there. It works just the same, but your idea of keeping the FEN on the stack as opposed to the whole object is a lot better. It's just a string that we could always decode back into a board. Smart. Self.update bitboard. So data should go one way basically. Data goes from move input. Move input updates the piece map. Piece map updates the relevant bitboards. Bitboards never send data back to the position. Hey Sidhunt, good to see you again. All right, so data flows from make move, wherever that happens, into the position, into the bitboards. From there, the bitboards can provide an FEN. Actually, no, it's the position that provides the FEN. Bitboard will go to search. Okay. So it's almost like I need a global store of the current, like I need a singleton almost of a bitboard to reference. The bitboard never needs to be, there never needs to be more than one collection of bitboards that are used. So there's a collection of bitboards. There's never more than one board instance where I am keeping all of this. There never needs to be more than really one of this service. I don't really know how the search is going to work though. All right, one step at a time. Appreciate you guys for some reason sticking around watching me work my way through this. Can we make a game? Kernel, restart, and run all. Obviously, we have no way to pass moves, but I should have a piece list. Right. The bitboards I will have to update will be like these bitboards. The piece location, the piece group bitboards. So they're initialized in their starting position, and then after each move, I update all of the piece groups and all of the attacked squares. Because then we can do stuff like bitwise and the attacked squares with the other pieces, sort of like in one of these examples, this one. So like the black pieces bitboard would have to have been updated with the the knight bitboard would have to have been updated. No, the knight bitboard isn't updated. It exists for every square at the start. But the black pieces would have to be updated to know which black pieces were attacked. Yeah, I'm not sure how promotions are going to work yet, but that's a good point. I don't think the bitboards are static. It's just there are static bitboards. There are a few static bitboards. So like the bitboards that never change are things like queen side, king side, center, center squares, flank. These bitboards are static. The knight attack squares are static because there's defined knight attack squares for each of the 64 squares. But the black position and white position bitboards are dynamic, and the squares that sliding pieces attack are dynamic, I guess. But we'll see. All right, so name position is not defined. So let's go back to game. From position, import position. What's not defined? Name position. Did I not import it? Oh, spelling error. All right, I'm going to make a new notebook for this one as well. So file, new notebook, Python 3. What do we call this one? Bitboard notes. This one is going to be game notes. from game, import game, from position, import position. Game is a new game. Board is not defined. From board, import board. Board is not defined. Can I not save it? Still not defined. Oh, this is in position. From board, import board as BB. Why did I do that? List attribute has no, list object has no attribute push. Python stack push. Sure it does, right? X equal to 1, 2, 3. X dot push 1. No. I know there's the DQ light, there's the DQ built in, but I want a LIFO stack. Oh yeah, duh. Just do, oh man, I'm like, this is why I should take breaks. All right, so obviously it's just a pen, it's just a list. It's just that the stack is popping from the stack. We can still use pop. Okay. So instead of push, and this is in game. All right, so we have a game. We should be able to get the game position by saying game dot get current position. What happens on a Python list if I only have one? Okay. So let's see what's on this thing. Sorry. So we can do position is equal to game dot get current position dot position dot board dot. This is what I didn't want on everything, but that's what's going to currently be on everything. But see how it's like nonsense to keep most of this on every single board, or in every single position. That's okay. Really, if we want to look at the position, we can look at from board, import board. We can look at the black pieces bitboard. And the white pieces bitboard. And if we call this whiteboard, blackboard, white pieces, black pieces, and we can do board.prettyprint I'm going to say from board import prettyprint bb as pprint. Now I'm going to do pprint white pieces. Oh, I just named them backwards. I was going to say, do I have a bug in the bitboard? No. Board is no object. Back. Okay, gotcha. Alright, so there's the white pieces. There's the black pieces. I think before I log off, I'm going to try to get one move generated. And then if we do white pieces or black pieces, this is what's cool about the bitboards, is that they logically sum. Alright, so we have this game instance. To which we can add a position. Position is position where our make move is. Position is where our make move is. So let's implement make move. We need a move, which is a piece from square to square. I don't even care if it's a legal move. Let's just put a piece on another square to begin with. Yeah, it is cool to be able to just do logical operations with these bitboards. I think it'll get a lot more interesting when we're looking at attacks and things like that. So let's do a make move on the position. Forget about if it's not a legal move. For the time being. So we need to make this. So we need to implement the quasi-legal move check, which checks everything except whether or not like the king is in check. Which I'm not going to worry about. I'm not even going to worry about whether or not it's a legal chess move to begin with. Basically, what I want to say is for some move, self.update bitboards.move. So self.piecemap at the location move.from. Oh, it's not a dictionary, so we should be able to say move.from. Pieces always vacate. So we're going to put this as the piece.empty. Self.piecemap move.to. I think I did from square like this. To square is equal to move.piece. So if we go back to move, move.piece from skew to square, from square to square. Self.date update bitboards. So actually I just want to pass the piece map. And this is a position. but I want this position to generate the next position. So a position has the bitboards on it. I want to create a new bitboard for the positions of all the pieces and any of the other bitboards I need to update. And I want to return that by creating a new position and setting the board on it. So we can do board is equal to, no, we can do this. There's this thing in Python with setting state inside of the parameters like this. You don't want to do this typically. It does not behave in a way that you might think. So we'll do if board is null, create a new bitboard, else self.board is equal to board. So now when we update bitboards, what I want to do is really say generate another get new bitboards. Bitboards are encapsulated by this board object that I got that's really bloated. New board is equal to, self dot get new bitboards for the piece map. I'm sure that this is just complete garbage, but not going to worry about castle rights around passant yet. And I could probably initialize this position with some type of dictionary. Self.piecemap. So self.piecemap. Should the game generate the new position? Yeah, maybe so. Let me think for a second here. The game is tracking a stack of, if you start from the previous position, you pass it to make move, and you add it to the stack. That may be true. I'm going to make a note for that. I think that might be a better approach. Something already feels kind of janky about what I'm doing, so notes to do should game generate new positions. instead. Yeah, possibly. That's a good idea, Alvaro. I have to think about that. Hey, what's up, Brian? Advent of code. Yeah, I think I looked at it briefly earlier today. I didn't start this one yet. So you've got these bags. White bags contain 1 shiny gold. Yellow bags contain 2 shiny gold, 9 faded blue. Dark olive bags contain 3 faded blue. So the required contents for 9 bag types. This example, every faded blue bag is empty. Every vibrant plum bag contains 11 bags. You have a shiny gold bag if you wanted to carry it on. The number of bag colors that can eventually contain at least 1 shiny gold bag. This looks a bit like a DAG, maybe? A graph? I'm not sure. I had to play catch up the other day with Advent of Code. It's the first year that I've actually played it. All right. Alvaro says, what I mean is since you're storing the positions inside stacks instead of position representations, you're implicitly generating the next one as you make the make move. Yep, I'm generating. Oh, yeah, okay, wait. And so if I'm generating the position here, I should be able to, well, for one thing, why would I return a new position? Position is just generating these FENs and pushing them on the stack, so. Oh yeah, I'm gonna have to take a break here shortly. All right, I want to do 2 things. Self-board. Man, Alvaro, you've caught like 3 bugs. Thanks, good catch. Thank you very much. All right. So we got this position object. So maybe it's the case since we're pushing FENs on the stack that we only ever really even need 1 position at any given time. So I don't need to initialize this with much at this point, I think. Breaks are for weeks. uh, all right, so I'm going to remove the ability to initialize some of this stuff for the time being. I will be able to create a position from a board. So make move is going to say, all right, is it a legal move? And we're going to use the pseudo or the quasi legal move check version. Take the from square, take the to square, set the from square to piece.empty, set the to square to move.piece, say get a new set of bitboards, using the piece map, which has just been mutated. Then change whose turn it is to move. And then push this on and then generate to FEN. Now if game calls make move just returns an FEN. Position is tracking the new state on its piece map. It's updated the bitboard, so presumably when we write search can use that position object with the board on it or the bitboard service. All right. Let's see if we can make a super hacky move. For that to manifest in the visualization, we need to update the bitboard since bitboards are used to make the visualizations. And what do we do with this new board? Self.board. Piece map is on the All right, so let's do a hacky version of updating the piece map on the bitboard, and then I'm going to play another game of chess. If anyone wants to play, feel free to challenge me on Lichess at Westman or chess.com at Westoil if you prefer. All right, so let's create this. You're not using your new board, it only exists on the make move instance. Yeah, I'm just gonna mutate the instance, the position instance. I will probably have to change much of this. I just want to get basic sequence out where we can move an actual piece and then observe the bitboard update in Jupyter. Okay. FEN needs what? The thing is, the FEN needs previous state for its next state to exist because we need to know how many half moves have been made since the last non-reversible move. We need to know about castling rights, and we need to know about en passant target squares. So we can get we need to make sure that that stuff gets updated. We need to make sure castle rights gets updated and en passant target gets updated. because that needs to go on the FEN. So to half move updates. So right now I'm just setting them to themselves because I don't have a way to update them yet. Half move clock is just going to plus equals 1, I guess. So all of this is currently implying that there's only ever one, there's a singleton instance of a position object, and there's also a singleton instance of a bitboard. I keep saying bitboard. The board class encapsulates many bitboards. All right, so let's call this update position on bitboard. I'm going to put it here. Didn't I already start this? No. All right, so this is going to take a piece map, but this is going to be really easy now. Because in positions, a piece map looks like this. For keys, it has squares. In a 64 64 position numpy array, and values, it's got piece codes. So I'm sure there's a much more efficient way to do this, but for key in piece map dot keys, now I feel like make move needs to be in the board class for some reason. Let me just think about this for a second. Oh, there's a global bitboard in this. Self.bb. But that's not what I need. Hey Sid Snake, the theme is in Vim, it's dog run. I believe this color palette is available for other editors as well. It's going to look a little bit different in my terminal because I have a different background color, I think, but it works well for Vim. All right, I got to think about how to update the position bitboards. I keep wanting to come back to this question. On the chess stack exchange. This guy gives a good explanation of representing bitboards. The question the guy asked was, I understand how to find all the valid moves for all pieces on a board. For example, I know that a certain knight can hit all the ones on this. So we have something very similar. Just kind of how I found this. We look back at the other one. No problem, Sid Snake. We look back at the original notes. I was also able to get to the point where we can represent knight attacks on bitboards. So I felt like the person asking this question was in a similar spot. And they're trying to say, how do we store these as individual moves and apply them to bitboards? Oh, thanks, Sid Snake. I'm glad you liked it. I'll have another one out before the end of the year with a little more in-depth dive into .NET 5 and Vue, and it'll be building a CMS. So we'll have login and sign up. The API is not running, so nothing is nothing is showing right now. But sneak preview. Nice. Yeah. Let me know how it goes if you try TDD with Flask or Fast API, which I'm not familiar with. Nice. What is this? Is this PHP? Oh, Python. Very cool. Yeah, let me know how it goes. Thanks for telling me about Fast API. All right, so this guy is basically at the spot where we are, and this guy stored moves in a struct. So this is like C# basically, or maybe Rust. Move info, char move to, origin and destination squares. I guess I could store that in a Python tuple. That's probably a good idea. Piece, captured piece, capture, can castle, is castle, en passant, promotion, promotion. Our move struct, if you will, class looks pretty similar actually. But from square and to square could be squares, and from square could be squares 0, and to square could be squares 1. But then this other guy went into a lot more detail, slightly not answering exactly the question, but it had a lot of good information. We have this structure actually, where we have every bitboard for every landing square for a knight, which is 64 bitboards. And ours is a lot larger than 512 bytes because we're using Python. Now we can determine the possible landing locations of a knight at any location just by looking at the corresponding entry in the table. So that makes sense. I mean, that's that constant time lookup that we get with bitboards in this case. These are all static bitboards. They're just there for your convenience when programming, but you'll probably want some active bitboards to represent the state of the game. So this is kind of what we need to work on. And we'll want a bitboard that represents where all the pieces are. So we actually have the starting positions. What if, okay, now I'm starting to get a little bit, Shout out to Alvaro for keep preventing me from taking a break. And now maybe having a slight breakthrough. The bitboard doesn't care inherently about any more than it represents. So for the white pieces bitboard, There's nothing encoded in the white pieces bitboard. Let's just take the white pawns bitboard, for instance. Or the white knights. It's not like which knight, it's just the knights. It's just the squares that the knights are on. It's not which pawn, it's just the squares that the pawns are on. Now I almost wish I had a dictionary of pieces and the list of squares that they're all on. Like an inverse of the current dictionary. Why do we have a square-centric piece list? Thanks, Brian. Catch you next time, man. When this is all said and done, I'll create a proper video series looking at what became of it all. Later. Okay. So now, kind of wondering why in position. So I want to invert this dictionary now, see if this works better for us. So what I want to say is something like this. Self.piecemap piece.whitepawns is equal to do you really need that? I mean, a movement is pretty much a dump position where you check if there's any inconsistencies. Maybe. I may have lost the thread a little bit. I'm not totally sure. Also, Alvaro, I would say if you think of anything that doesn't look right, or you have any other like questions about the specifics in here, maybe if you wanted to leave them as notes like in the GitHub repo, I'm totally cool with that too if you made a pull request. Not saying that you have to by any means. Keep asking me here. I'm just throwing it out there in case I missed something or etc. All right, so self.piecemap. I'm gonna say piece.whiterooks is equal to 0 and 7. We'll make these tuples. No, we'll make them. They gotta change. So I'm gonna make them here. Yeah, we do have to make sure that the piece can move. Not sure exactly yet. I think we got to use I think we can use the bitboards for attacking squares, because the attacking squares for any piece will define its legal moves. The attacked squares, I should say. So piece map piece.white knights are on 1 and 6. Piece.white bishops are on 2 and 5. This might all be completely backwards, but I will explain my thought process here next. It's going back to that square-centric idea of board representation in a way, I think. Oh man, Alvaro, you're in Spain. That's crazy. Yeah, it's super late slash early there right now, man. Oh, always wanted to take a trip to Spain sometime. Occasionally, what was I gonna say? There's a fun game called Geoguessr. I used to play this on live stream now and then. There's some live streamers out there who play this. And I'm pretty sure they have a Spain challenge. Yeah. But I can't remember what the name of the map is that I used to play, and I also don't remember what my login is. Well, there we go. I don't remember what the password is. But if you haven't played this game, it's really fun. Basically, it drops you in a random Google Street View, and then you have to guess your location on a map before time runs out. Let's see. I'm going to try to log in. I'm not sure I can remember my password here. Yeah, no dice. I'll try to reset. I'll play one round of Geoguessr. Maybe one more game of chess. Oh, you see me play it? And I did not cheat. Let's see. Set a password. Alright, I'm going to play one game of Geoguessr and then go back to the chess programming. I think it was called Diverse Worlds. Alright, I haven't played this in months. Looks like they updated their UI a little bit. No time limit moving allowed. We're going to set a time per round. Alright, I gotta do a blitz round. So we'll do 1 minute per round. Bullet round, I guess. Oh, it's been so long since I did this. So this looks pretty Nordic. But we got language over here. Hayatala, that looks like Finnish a little bit, maybe. Oh, we only got a minute. Oh, man. And of course the sign is blurred out. I need some language blurred out. Well, I'm guessing way up north, Northern Europe. And the first thing I saw reminded me a little bit of Finland. So we're going Finland. I don't know. Finland over here somewhere? It's way more populated over here, so maybe we'll go on the other side. We'll go down here. I have no idea, but I'm pretty sure we're in Finland. Man, we're in Finland, but we were way up north. Okay, next round. Cinturon, Seguridad. Big B Forever is guessing Iceland on that last one. We were both close. Alright, so San Jose, Caldera. Atrévete a darles un mejor futuro. I'm going to run out of time and I have no idea where we are. Oh, Costa Rica somewhere. Because I see the CR. Maybe? All right. 9.5 miles. It's all about those signs when you catch the domain suffix. All right. Bada bing. This looks like some beautiful New Zealand. I'm not sure. This could be Brazil. So the soil is really red here. I would love to find a sign. We're just about running out of time here. Can I get a look at what we look like here? Man, this is hard. This is really hard one. I don't have any Spanish accent. I'm not sure where we are at all in this one. Maybe in Australia somewhere. Oh, luckily I didn't click away in time. I was guessing in Namibia, but we were in Lesotho. Very good. Have a friend who lives in Botswana. More like a friend of my wife actually, but I've never been. All right, next round. Where are we at? Where are we currently? So the chat is like 30 seconds behind as well. So by the time the round is over, I usually miss you guys. All right, so I see some stuff down here that looks Polish. No. Interesting mix of languages there. This 1 minute is not good enough. Gonna go Southern Europe, but I don't really know. Serbia, maybe? No, but Bulgaria? Bulgaria. Probably way off. Romania. That's why we saw Spanish. Romanian and Spanish look pretty similar. All right. Next round. Oh, look at this. This is like the view outside my window. Just kidding. I have no idea where this is. The earth is red. And we've definitely got like some massive savanna. So I'm guessing Australia, but this could also be plenty of other places. Oh, that's right, Big B. I remember you saying that you were from New Zealand. I'm not sure about this one. I was going to say Australia, but Big B, you would know better than I would, being much closer. Um, I'm going Western Australia. Oh, so close. All right. Not bad. This isn't my worst one ever. We'll play one more. I like the 1 minute rule. I don't know. This looks like some suburban United States a little bit, but the sign didn't look like the US so much. Canada, maybe? Let's go take a look at a road sign up here. This is North America, though, I think. North Branch Cass River. I don't know. Seems like northern US. Maybe Canada. Yeah, this is in Canada. I'm going to go Nova Scotia over here somewhere. Maybe Quebec. Maybe Nova Scotia. I'm going Nova Scotia. Maybe it's further east. Wow, this was in Michigan? All right. That's pretty far from where I clicked. It looks close, but that's like almost 1,000 miles away. All right, so here, what does this look like? This could be Scotland, England, although that log house back there didn't really look like it. All right, I'm not even gonna say anything about what that is. But yeah, what could this be? Looks like a almost like a Catholic kind of shrine there. Oh, and I missed the signpost here. Oh, Clayui or something, man. That's gonna be Northern Europe. I'm not sure where. Hmm. I was close. Same country, but always helps when you find a sign. All right, so what do we got going on now? All right, so yeah, this is obviously Southeast Asia. I wish I was more quick at understanding what. Oh, I have a feeling that we're in Cambodia. So we're gonna come back over here. Wales, Big B says. Probably for the last one. So I don't know. Phnom Penh's a big city, right? Phnom Penh. So I'll put somewhere in center of Cambodia just so we can hedge our bets. The sign, yeah, the signs are. If you land next to a sign, it's usually you can land least within the country. All right, what do we have here? What round is this? 4 or 5. This looks like your everyday small town USA. Small town USA. Maybe like Iowa. There's just a dude walking. It's the street name. Benrock Terrace. No idea. Definitely in the US, but question is where? I wish I could tell what that sign is. Alright, well, I'm going to run out of time if I don't drop it somewhere. I mean, I'm going to guess Michigan, but I have no idea. Okay, Florida. Apparently, I'm worst at my own country. Starwood Superette. No one else offers a plan like this. All right, so that looks like kind of Hawaiian with those palm trees. Although this store doesn't look like what I would expect to see in Hawaii. but they speak English. This could be Guam. Oh, this is New Zealand. Big B, where are you at? Maybe in what's the Dunedin? I don't know how to say Dunedin. There's some of my favorite bands from the '90s from Dunedin. Though I might not be saying the name correctly. All right, shout outs to Big B for getting a GeoGuessr in his home country. How do you say Dunedin? I might be saying it completely wrong. There were some good rock bands from this place, and not Dunedin, Florida, obviously. Named for Dunedin. Dunedin. Sorry, Dunedin. Dunedin. Sorry about that. I'm not very cultured. Dunedin. Yeah, there's a band from here. There's a couple of bands. The Verlaines. It's a good band. The 3Ds. I think the Bats are from Dunedin. At least I know how to say it now. No, the Bats are. Oh, yeah. The Bats from New Zealand are also from Dunedin, I think. Oh, they're from Christchurch, New Zealand. But they have the Dunedin sound, it says. There's a couple other good bands, if I can remember. Oh, we could click on this. That label Flying Nun was from there. Let's see. There's a Verlaine song, "Death in the Maiden," which I really love. And I like all the 3Ds albums. Yeah, this is a good jam from 1983. Good stuff. So a lot of good music. All right. One more game of chess and then back to the chess programming, and then I'll wrap things up in 10 minutes. We got basic move generation almost done for illegal moves. Maybe next live stream I'll work on. Maybe next live stream I'll work on move checking. All right. I don't know why I'm playing on chess.com now instead of Chess, but also I feel like I haven't had. Have I had any black games tonight? I don't think so. Playing something I really don't know how to play. I have a feeling this isn't particularly good for white though. Yeah, I'm pretty sure this isn't good for white. Could be wrong though. What kind of notation for Python? Yeah, that's a good question. I think I'm losing a pawn here. So I must have misplayed this because I think after bishop g7 he plays rook d7. Notation wise, I've never really been a strict Google Doc or PyDoc variation. Normally my doc strings just look like this. but I have never formatted them to a specific standard. Oh, and he doesn't have bishop d7, obviously. Man. All right. I still don't like my position very much. White's got more development. And a bit more space. My king is a little bit safer until the next move. But then I could even trade off the knight and open up his king if he decides to castle. I kind of expect just like rook d2 here. Okay, rook d5. What about e6? What's his point? Okay. I'm just going to develop. So now, just putting more pressure on the e5 pawn. I don't think he can castle yet, because I'll just take the knight and open up a file against his king. Here, though, I think I can win a pawn. So I was able to win this pawn, and then if he were to play rook c7, I would have been able to take with check. King moves, then I guess he would have had rook b7. So maybe I didn't win a pawn, but now I'm going to try and clean up my pawn structure a little bit. And work on kicking this rook back. Actually, his rook's out of squares. Am I moving towards Python? No, not in particular. Just for a lot of times for smaller projects, I do like using Python. And I use both professionally, so both C# and Python professionally, and JavaScript, mostly TypeScript with Vue, and some Express at work as well. But it just varies by project. What about you, Big B? Ugh. So now he plays h6 and my king gets forced back to h8. I didn't really play this super well. Although now... Sometimes I wonder if I should be trying out more languages for the channel or if I should really just be focused on the .NET stuff. There's some more data science and machine learning that I'd like to do as well. Do I use some Java stuff? I have only worked on one Java project in my career. And many years ago, I did a little bit of Android development when I was first sort of learning. So his idea now is to play rook d6 and checkmate me. So I'm going to avoid that. And I may even give up the exchange. My position's not that much better at the moment. my king is stuck on h8 forever. Ugh. Yeah, I played that horribly. I think the position's still winning if I hadn't repeated. Horrible. I was winning and then I repeated moves. Alright. That was nonsense. Alright, let's quickly in the last maybe 15 minutes, I'm going to wrap this up and make use of this inverse piece map that I created. So update position comes into here. Position has a piece map where I place the pieces into position using arrays. And then we can replace these here. White pieces are there. 48 to 56 is here. Black rooks are on 56 and 63. Black knight is on 57 and 62. Black bishop is on 58 and 61. 59 and 60. You guys watch any chess streamers like Hikaru or Hikaru being much more than just a chess streamer, but also one of the strongest players in the US? All right, so for we can get rid of these. This year, since COVID, chess streaming has really taken off. So now we have a piece map that actually maps pieces to squares, and the idea here is that piece map, when this is going to mess up the make move though. This is going to mess up the make move. The idea was though that when this gets down to the board, we can say for key and piece map dot keys. If key is self dot White pawn bitboard is a numpy array with 1 at each of the indices that are in the value here. So we can go, so we can actually do for key val in piecemap.items. Not actually in the industry, but you have a software engineering degree, practice.net. Nice. Yeah, .NET's it's still probably my favorite framework to use for backend web development. Definitely. And even like the Blazor stuff for front end is really nice as well. Okay, so numpy change indices using list. Okay, so it's gonna look something like self.white. It'll be np.put self.white val 1 length. We need to get an array that's a length of ones, list a length that's ones. So we can go 1 for I and length of val. So the idea here is that we have something like np.array. We have something like this. And then we do np.putx. And we want to say in indices like the 0th and the 3rd. So we'll say like the new hot is 0, 3. We can say new hot and then val for in length. Yeah, 1 for hot in length of new hot. Int object is not iterable. So if I did ones times 4, all right, so d type is equal to byte. All right, so here we can just say np.ones length of, get rid of all this list comprehension stuff, np.ones length of new hot, d type is byte, and then x has been updated now, the correct indices. Yeah, thanks, Ray. That's a good call. That's what I messed up, but I'm gonna use np.ones just to use numpy, I guess. But you're right. You are right. np.ones, or sorry, np.put. I just did np.put. Now I'm losing my mind. np.ones. Here we just do length of val. Type, dtype is bytes. I don't like how expensive this entire thing is, this operation. First of all, I need to zero out the white piece bitmap. Numpy zero out existing array. A dot fill zeros. So self dot yp dot bb dot fill zero. So if I did x dot fill zero, that makes it go back to 0. So we're going to iterate through this piece map. For every piece that's left in the map, we need to turn the bits hot wherever those pieces exist. And I can use a dictionary to do this to make the mapping even more terse. So I'm going to stop here shortly. Let's put the to do to finish map translation. And I'm sure that there is much more elegant ways to do this. But I want to fix this very quickly. So when we have the pieces as keys that have arrays of the positions of those pieces, it makes it much more difficult to do the lookup for the from square and to square. If I made these sets then we have almost like what reminds me of a postings list in a search engine. An inverted index is what it looks like. So now at least, so what I can do is self.pieceMap move.piece. So the two steps are empty pieces existing spot and put piece into new spots. Still feel like at some point I need this empty piece, but now in the piece map, what we do is the piece map at move.piece. So this gets us the set. dot remove piece dot to from square piece dot append piece dot to square. Got to do castle rights and en passant target. Let me update the bitboard. Let me call update bitboard. What happens? It's going to be update position with a piece map. So that happens. Switches sides to move. And so far I've updated the white position for pawns only. So let's see what happens. This will be the last thing that I do tonight. Restart and run everything. Okay. Initial position. Take it easy, Big B. Thanks for stopping by. Position takes a board. Board is null. Board none. Okay. All right, so we got the position. Position, make move. We just got to pass it a move. And the way the move looks, self piece squares. So we got piece is piece dot white pawn, let's say, because that's the only ones that I'm checking so far. Squares is piece square. What did I call squares and constants? Square position. As SQ. SQ dot E4. SQ dot E2 to E4. Okay, and then make move is in position. and move, sorry. Is capture, is promotion. All right, so move is not defined. For move, import move. Is legal move, takes 1. That's just a bug or a typo on my part. Legal move. Key error 1. Position make move. Self.piecemap move.piece. Piece map is empty. Set initial piece looks. Set initial piece looks is not defined. Position object has no attribute piece map. Oh. All right, name piece is not defined. This is in what? Position.make move. Position line 50 piece map, remove piece from square. I see. Getting there. Set object has no attribute append. Add, I think. Can I do this? Yes. Okay, in argument must be a string bytes length subject or a number, not a set. P.put and P.ones length of value. This is going to be in board.py. Update. Position. Self.white piece bitboard. Val. I see. Why is that val a set of everything? All right, so we've made a move in the position. Next thing is to look at I'm not sure if I need to now update the white pieces bitboard. Board is none. Board is somehow wiped out. Piece map, is that updated? So here's what the next thing I want to do is I want to look at the piece map before and after. So the piece map did get updated. We had 8, 9, 10, 11, 12, 13, 14, 15. Now we have 8, 9, 10, 11, 13, 14, 15, 28. So the pawn moved. Self.whitepawn.bitboard.fill. Come back to the position. Oh, update bitboard's not returning anything. Alright, so this is all kind of janky, but self.board should be updating the board instance on itself, right? So we don't need to set this. Kernel restart and run all. That's right. Self.board.white pieces. Looks like the pawns didn't actually get updated on the instance. So here's what I'm going to do is return this self.board is equal to this one. Update position on board. And the position. This is all hacky. I was going to OR the white and black positions together here and return them, but I just want to reference the white pawn bitboard directly on this instance. So it didn't actually change the position of the pawns, right? So but it updated the piece map. So the piece map got updated. Did we pass the new piece map? Update bitboard gets the new piece map. Update position. Placing pawns on, these are the new squares. 8, 9, 10, 11, 13, 14, 15, 28. We fill the white pawns with zeros. We put if I were to call np.put self.white p.bb is equal to, doesn't mutate it in place. No, it does mutate it in place. So why doesn't it place a 1 on? Oh, it's not the length of it. It's just 1. Okay, so if it's not the length of it, it's just 1. Let's try that. X is not defined. Yes, I know. Unmatched brace in D-type bytes. Gotcha. All right, let's give this one a shot. Kernel restart, run all. Put dispatcher got unexpected keyword argument D-type. And np.put does not mutate, or it does mutate. So now the question is, why does the white piece bitboard not actually get updated? If we were to say np.put white position piece bitboard, and we put on square 60, 61, and 62, 1. And then we were to look at this, it mutates it. So what am I not doing correctly here? Placing white pawns on 8, 9, and 28. Where is this coming from? Did I just not save it or something? So confused. Position.py line 69. Okay, I guess I hadn't saved it. So that bitboard looks totally messed up. I'm not sure why. Eight, 9, 10, 11, 13. So 8, 9. Oh, no. It looks correct. It looks correct.